When they want to build a segment tree and they want to initialize the array for this segment tree, what is the question? How many nodes we need to be in this array? For example, here we have some array, for example, 5 elements. So n elements, so 5, for example. The simplest way to build a segment tree is to expand this array for the number of S elements which are represented by this expression. So we have the 2 power of log logarithm under the base 2 for n, and we take the upper bound. And for this case it will be 8 elements. So we expand it. Also we know that in the full binary tree or in a perfect tree, they know that the number of the internal nodes is equal number of leaves minus 1. So we can represent all the needed nodes as this formula: x equal to 2l minus 1. The l is the number of the leaves. So this is 8 in this case. And we can take this x number, for this example this will be 17, and initialize the array of this size. And that's okay. But what if we don't want to expand this our initial array to the number of s? What we can do? We can use this formula. We can just take our n number of our initial nodes and multiply them by 4, and we'll have this size of array which we can use. But how can we prove that this is correct? Okay, we can see that this number of s is by definition is greater or equal than our n. Okay, but it is also less than the 2n. Let's prove this by contradiction. Suppose our s is greater than 2n. So from here we can say that s divided by 2 is greater or equal than n. But here they can see that this thing is a power of 2 and it's greater than n. But the in the at the start has this statement that s is greater than or equal than n. So this is the maximum number. But here they find that exists some power of 2 which is greater than n but less than our s. So we need the s to be the most minimal power of 2 but greater than our n. But here we find that exists some less s, and this can't be. So we have contradiction with our this definition. So we can conclude that this thing can't happen. So this is incorrect. Okay, this is incorrect. And now let's so we have this relation. Now let's okay, now let's use some. So we have this, we know that s is less than 2n. Now we can multiply it by 2 from both sides. And also from both sides you can subtract 1. We have 4 here. And now if I subtract 1 from both sides, we can see that we have this formula here, this expression, and actually this is the total number of the nodes in a perfect tree or a full binary tree. And so this means that we can say that the total number of the nodes which we need is less than this value. And also we can say that our tree, which has n leaves, all this will have less elements than this thing. So we can, I don't know, write it like this. No, we don't need to write this. So we can just say that if there is some function which return to us there, so we provide the n length of the our initial array, and this function returns the number of nodes. We can say that this number is always less than this thing if we expand our initial array for this array, this perfect array. and this will hold. So they can say that the total number of nodes that you represented here is less than this value, and this of course less than this value. So this means they proved this thing. They proved that we can take our number of elements n and multiply it by 4, and this size of the array is enough to build our segment tree for our initial array.